Okay, Tim asked me about time on Twitter, and I realized that yes, time is definitely something that falls under things that are harder than you think. The main reason is that in a single game, there can be a multitude of different ways that you are tracking time and different meanings for that time. So let me see if I can't list off all of the different kinds of time you're taking into account. You have some sort of delta T for every single thread that's measuring how long it's been since each thread has run. And it needs to properly accommodate pausing in all the various different permutations of pausing, including things like special gameplay modes where you might be pausing game effects but not anything else, or actual pause, or the UI screen. Each thread needs to accommodate all of these different kinds of pauses as appropriate for what it's handling, which means it needs to be able to handle adjusting its delta T when it recovers from pause. You have the concept of durations, which will be measured in seconds or minutes caused by spells and effects. You have the concept of minutes and hours, which are measuring the time of day and the length of time it takes to get from one place to another. And those are likely not synchronized with your effects timings because the two things may not be something you want to have synchronized. You have time of day, where you are determining where the sun is in the sky. Your time of day may or may not be actually tied to the time it is in the world. And the passage of day-night cycles may or may not be attached to your calendar time because you may not want your days to be passing at the rate of your day-night cycle. You may have something like time stop, where you want to pause most of gameplay but allow some parts of it to continue running and updating some parts of them while not updating others. You have some systems that need to be very deterministic and need to handle time in a very repeatable way. Some of your systems are going to need to be aware of the system time of the computer or console that the game is running on in order to timestamp a save game or to mark the passage of time for long wait events. And then if you are multiplayer, you have a synchronization between the client and a server or between multiple clients that adds a multitude of additional sources of truth for your idea of time. There isn't really a clean way to do this, so we'll sort of make our way bumbling through video game history a little bit. If you go back in time to the early days, there was basically only a single way that time was kept track of, and that was a tick counter. You ran through your game loop as fast as you could, and when you finished it, you started a new one. At this point in time, we aren't multi-threaded, so there's just the one loop that's running as quickly as it can. If you wanted to keep track of time, you just added up frame ticks, and that's how you knew how much time went by. For things that expired, you just decremented a frame counter every time you updated them. When the counter got to 0, the thing expired and you were done. This is how video games did it in the very early days. The games are relatively simple. They don't need a concept of time beyond some things that last a few seconds. Everything else is pretty much happening in real time. There's some advantages to a frame counter being your only concept of time, because it means that if you just stop updating frames, the game will stop updating. So you have a pause kind of shaking out of the system almost for free. And you can probably see some pretty big problems with this if your loops start running unexpectedly quickly. If you look at some games from long enough ago, when you try to run them on a modern computer, they run at thousands or even tens of thousands of frames a second, and the gameplay isn't handling this. So things that were supposed to happen in 10 seconds when the game was running at 30 frames a second are now happening in a tenth of a second because the game is running at 3,000 frames a second. So that's a problem. Of course, the reverse is true as well. If your computer isn't keeping up with the expected frame rate, then what's actually happening is time is simply going slower than expected. This sometimes can make a game easier to play, because rather than having an unresponsive game that is jerkily jumping through time, you're just having a game that's running at 50% speed as the game loop is just running as fast as it can, and everything is slowing down to stay in sync with that slower frame rate. It doesn't necessarily make the game fun, but it often can make it more playable. If you go a little bit forward in time, you get something that's more like what Baldur's Gate does in its gameplay loop, which is a throttled tick. Baldur's Gate is multi-threaded. It has a rendering thread as well as a gameplay thread. The rendering thread runs as fast as it can, but the gameplay thread will not run faster than 30 frames a second. But it doesn't do anything to take into account that it might be running less than 30 frames a second. If you're running it on a super powered computer, then the gameplay loop never goes above 30 frames a second. In fact, there's a few tricks under the hood to make it perform better, so it's kind of running actually at half that, but it doesn't matter. But if you get it on a really low-end computer where it's running slower, the game just slows down. You move slower, visual effects move slower, because all of the updates for animation and position were done in the gameplay loop, not in the rendering loop. So at this point, we're still pretty clean in terms of dealing with multiple authorities on time. There is a delta t being used in the rendering thread, but because the gameplay thread is completely authoritative on everything, on animation, on movement, on visual effects, on projectiles, on game effects, on all of that, it basically just controls everything. But in Baldur's Gate, what you do start to see is that we have multiple forms of time at different levels of gameplay. You have frame counters at the base game level, but you also have the concept of time of day, because Baldur's Gate has a dynamic time of day. The game has night and day and sunrise and sunset, and it's running on a timer. And as well, there's at least one plot in Baldur's Gate 1 which is timer based, that is based upon you doing something fast enough to not die of a poison you've been inflicted with. Another level of complexity start to enter into the conversation, because you're having to deal with different concepts of time within the gameplay, ideas of days and hours and time of day that may or may not be directly connected to that frame counter that you're using at the combat level. Additionally, you're starting to need to care about calendar time in the real world, because this is being used on your save games. And so you need to care about what time it is out in the real world, independent of the gameplay. Now, they're not all intricately tied together into a big Gordian knot, but they're all starting to rear their head, even at this point. So beyond this point, we're basically moving into the land of delta t. What's delta t? Delta t is where in a thread you are measuring the amount of time that has passed since the last time you did something. It could be done simply at the beginning of the loop in that thread, and you're just measuring how long it's been since the last time you started the loop. You could have finer delta t's within the actual loop updates itself. Why do we move from frame counters to delta t? The simple answer is that it is about smoothness, about fidelity, because with the frame counter you have a fixed time step no matter what happened, which means your game essentially has the ability to run only at a single frame rate, and it's either at that frame rate or it's basically doing something that's not expected. It has no ability to handle really departures from that. If you are running slower, then things are updating slower. If you're running faster, things are either updating faster or you're just throwing away the extra processing time that you potentially had available to do more interesting things. With the delta t, you are able to be more precise with exactly how much time has gone by. If only 16 milliseconds have gone by since the last time you updated, you can run the game at 60 frames a second instead of 30 frames a second. And this allows you to have smoother animations, smoother updates, more responsive controls, and it just gives a better overall fidelity. But as we'll see, it also comes comes at the cost of a lot of additional complexity, because with a frame counter, it's always a single step. If you skip an update, when you come back and update, it's as if a single update occurred. So there's no jumping through time. Everything can only move either not at all or one step forward. There is nothing else. You can't jump ahead a bunch of frames. You can't move through at a different rate. It's this staccato movement. If the game is running at 30 frames a second and you don't update a visual effects for 40 frames and then you update it, it updates a single frame forward. It moves 30 milliseconds into the future, not 40 seconds into the future. There are definitely some advantages to a frame count kind of system. Each system in your gameplay is relatively stable on its own, able to act independently of every other one and being updated essentially whenever it strikes your fancy. Because you are either incrementing frame counters or decrementing frame counters to keep track of the passage of time, there isn't really the need of a concept of a global time, because each system just kind of keeps track of its own local time and things aren't really talking to each other very much yet. And this allowed me to do things like implement time stop in the Baldur's Gate series, because you are able to climb down into the guts of each system, decide how it will respond to time stop individually, and then implement that behavior at a local level. And you don't have to worry about the impact it has upon the overarching system. So the animation systems don't update unless you're the person who casts time stop. The projectile system don't update at all. They just freeze all the projectiles. The game effects don't update unless you're the person who casts time stop. You're able to go into each and every individual system, handle time stop on its own, and not worry about the impact it has on the interlinked systems. Whereas in more modern game engines, you have this bi-directional control where the projectile system might cause game effects to come into being, and vice versa, where the particle system, which in a game like Baldur's Gate is completely a visual system, modern particle systems sometimes spawn game effects. So if you aren't pausing the particle system, you might have unintended game effects come into being when the game is paused. If you are measuring delta T, what happens when you pause the game? If you don't go into the gameplay loop when the game is paused, when you unpause the game, is the delta T, which would normally be 30 milliseconds, suddenly 15 seconds? And if it is, that's going to make things go pretty crazy. If you're using a delta T, rather than using countdowns to handle durations, the temptation would be to use expiration times. So when the time reaches this moment, then this visual effects expires, this game effect expires, the time of day changes. But if you do that, you need to realize that each of those different systems has a different concept of time, and so you may need to have several different timers that are updating independent of each other in order to allow you to do the things you need to do in your game. Because sometimes you're going to be advancing time for one timer, but not for another. Time of day is advancing, but game effects are not advancing. Animation is occurring, but AI is not running anymore. And maybe this is the root of a lot of the complexity here, because I asked about pausing the game, but that is actually maybe an oversimplification. Let's start there and then add complexity until maybe the point comes crystal clear. So when your game is paused, are you updating anything? Well, chances are you're updating something. You're going to let the player move the camera around, likely. So you need the part of your system that handles input as well as moving the camera to update. That might also require you to update some parts of your visual effects system, possibly, depending on what your camera is doing exactly. If I can go into the UI and equip an item, then the effects system that handles stats and the adding and removing of equipment needs to be updating at least enough to allow that equipping to occur. But you don't want effects to be expiring because the the game is paused, right? So you need the effect system to be updating enough to handle the equipping, update the person's stats because they put new armor on, but not have other effects that are going to have a duration expire. You need their appearance to update, and that might include potentially ticking the VFX system forward enough to allow particle systems to start spawning so that the armor that they have that's made of fire looks correct, even though the game is paused. And paused in and of itself is kind of a simplification. When you are in a conversation, the game isn't paused, animations are still playing, and you still have all of the visual effects systems running, but you probably don't want your game effect system running because you don't want people dying from some random dot in the world in the middle of the conversation when they can't do anything about it. You probably don't want combat AI running either because, again, you don't want people to run in and start attacking the player when they can't do anything about it. So you are entering into a situation where you're changing the interaction with time for different systems based upon different game modes, based upon different situations. Each of these changing the concept of time. When you're in a conversation, time is still passing from the perspective of the player. Time is still passing probably from the perspective of the world, but time isn't passing from the perspective of the game effects. So now you've diverged those two concepts of time. Additionally, we're now entering into an era where we just have a lot of different concepts of time. So we've been talking really low level up till now about how I determine how much time has gone by frame to frame. And if I am using the reality of how much time has gone by, or if I'm hard coding it to some sort of fixed number, or if I'm clamping it at a maximum. But as we move out to a larger concept of time, now we have to think about that because you have different systems that are reacting to time in different ways. If I cast a spell that has a specific duration, that needs to understand how much gameplay time has gone by. So you probably don't want pause to be taken into account for that. But some of your visual effects systems or particle systems or your simulations may not handle being paused very well. So you might have physics settle even though the game is paused. You see this occasionally in games where you pause the game and the water simulation keeps running, or the leaves on the trees keep moving, or the fire keeps flickering. It's not necessarily that their simulation is unstable when paused. It could be, or the other possibility is simply that they didn't bother to implement a pause for something that has no gameplay impact. So that isn't going to be taking into account gameplay time, it's taking into account some sort of accumulated delta T. But if you have physics triggered by casting a spell, now you've actually detached the two things, and the one thing, which is based on the passage of gameplay time and stops when the game is paused, and another which is unable to be paused, and so that hair settling is happening now earlier than you'd expect because I'm able to pause the game, let the hair settle, and then unpause, and now they're detached from each other. And this starts to become a problem across a multitude of different areas. Going all the way up to the very top, if you have a dynamic day-night cycle, chances are you are not running your day-night cycle on a 24-hour clock. I don't know that I can think of really very many games that do that. Usually it's much shorter than that. Say you even run it on a day-night cycle of 2 hours. So it takes 2 hours for the sun to come up, go through the sky, set, go through the night, and then come up again. That's a 2-hour clock. So, well, what does that mean for the passage of time in your game? Does your day still consist of 24 hours? And if it does, each of those hours, does it consist of 60 minutes? And does each of those minutes consist of 60 seconds? Because if so, each of those seconds is only as long as 1/12 of a normal second because you've smooshed everything down. Instead, probably what you want to do is detach this macro passage of time from the micro passage of time. But you do introduce an inconsistency here, because it means if I cast something with a relatively long duration, I can count the passage of time in spells expiring and realize that, yeah, the day is really short. The day's not actually 24 hours long at all. But then, do you want calendar time to be moving at this accelerated rate as well? Or is it really just a passage of time from a visual perspective? If I stand still for 4 hours, has 2 days gone by? Or has 2-day night cycles gone by? Are those things the same? One thing that you also need to keep in account is these days, games are pretty much all multi-threaded, which means you, at the very least, have a thread that's handling your rendering and a thread that's handling your gameplay loop. But chances are actually you have way more threads than that. And if you don't have a common understanding of time, then you have a lot of difficulty talking back and forth between your different threads. There are ways to avoid this crosstalk and make it a little bit easier, but it's something that you need to be aware of. If you have a thread that's handling visual effects updates, it doesn't necessarily need to worry about what time the gameplay loop understands. But if your visual effects have the ability to cause gameplay, if they have physics on them, or if they can apply effects, if you have embers that are running through the visual effects system that can light things on fire, now you're talking in both directions. You have one thread, the gameplay thread, that's causing visual effects to come into being. But if the visual effects can then cause gameplay, that back and forth actually makes the time communication even more complicated. And then finally, there are times when you want to know what time it is from the perspective of the real world. You might give a timed event that takes 24 hours of real time to go by. So how do you measure this? Is it based upon the calendar setting of the console or computer the game is being run on? And if it is, can I just set my date to something else to make it advance? And if it isn't, then what are you using to measure this passage of time? It can be useful to know how much real world time is being put into your game from a telemetry perspective. And actually players often are interested in this statistic as well. How are you measuring gameplay time? Is that simply something you measure by setting the clock when the game starts and then stopping it when it stops and then adding up all this time? Do you exclude certain things? This is another different time that you need to take into account. And none of this up till now has been taking into account multiplayer. Once you add multiplayer, now you have an entire, at least one other computer that has an opinion about all of these things, has an opinion about what time of day it is, has an opinion about how much time is going by, is updating things at a different rate than you, and depending on your determinism, possibly causing things to drift apart simply because of disagreement in time. In multiplayer, the solution is usually to empower one of the actors to be in control of the passage of time. But this can actually be a very powerful thing. If you have control of what time it is, if you're able to control everyone else's passage of time, this is definitely an opening for exploits. These are all things where I need to understand as the developer what's going on. It isn't necessarily things that you need to communicate to the player, but your game needs to understand, because if you are using one form of time when you should be using another form of time, then things are going to get out of sync very quickly. One thing that you'll see is that sometimes when determinism is very important, is it will lock as many of these time steps into synchronization as it can in order to improve determinism. Dragon Age Inquisition does this with cutscenes because there was something, I think, in the animation system that was non-deterministic. So if the cutscenes were allowed to run at whatever frame rate they were capable of, then they actually started to fall out of sync. And as I talked about in my replay video, it's actually really hard to keep things in sync, and introducing something where the floating point imprecision starts to come into play because frame rates aren't even consistent actually makes that much more difficult. Now, of course, locking your cutscenes to 30 frames a second isn't the best from a fidelity perspective, but it keeps the cutscenes actually running. This video is amazingly rambling because every time I broach a subject, 3 others come tumbling into my head. Sometimes I have a full script with a PowerPoint presentation behind these videos, and sometimes you have this single post-it note that I scrawled things that came to mind over about a week and then use that to record stream of consciousness wise. Sometimes it works out. Hopefully I get the point across, which is that there are a multitude of different ways and different types of time that you're going to be measuring in your video game, and you need to keep them apart because using the wrong time in a specific system is going to make it not work as expected. A special thanks to my members. They provide the resources that this channel needs to keep running. If you are interested in becoming a member, there's a link down in the description. If you found this interesting, please give this video a thumbs up because that will help it spread to more people. If you can think of some of the many different ways of measuring time that I'm not covering in this video, please let me know down in the comments. I will see you again soon. Thank you.